today I'm going to try to use, don't forget masks, please. Try to use black on this, which is Professor Butter's been wanting me to try that. All right, so last time what we were doing was looking at some tools of analysis, and we were looking at indifference curve analysis. And what we're going to try to do with this is two things. One is we're going to look at the income and substitution effects of a tax. I mean, this is some of the things we're going to do with this analysis. The other thing is we're going to be deriving those conditions that are necessary for Pareto optimality. Okay, and then we're going to show that markets lead to Pareto optimality. Okay, and then we'll talk about, okay, but when do you run into some problems? Externalities, public goods, that kind of thing. So last time we drew an indifference curve, and we had y, and we had good x. And then we noted that along an indifference curve, what's the idea? That the utility is constant, right? So we said that the derivative is equal to 0. And then we showed that how do you get to the derivative? We noted that it was the margin utility of x times the change in x plus the margin utility of y times the change in y. And it noted that was equal to 0. And if you just do the little basic mathematics, if you think about how you would do that, if you have 0 equals that, right? And then if all you do is you take the margin utility of y dy is equal to minus the margin utility of x dx. Right, if you just subtract off, I'm just doing the simple mathematics here. And then you divide both sides by dx. What do you get? You get, and you divide by margin utility of y. I don't know if I'm going to like this or not. That works. You'll get the y dx is equal to minus the margin utility of x over the margin utility of y. Right, just by dividing by dx and dividing by margin utility of y. And we said that at the end, we said, what is that equal to? That's equal to what we call the marginal rate of substitution, right? So think back to ECON 202. So what we did was we showed that the slope of the indifference curve was just equal to the ratio of the margin utilities. It's got a negative sign on there because the thing's downward sloping. Now, just a couple of, another thing to note about this is that why does it have that shape, right? Rod Stewart's Every Picture Tells a Story. Oh, I forgot. I have a band pick of the week this week. For those of you who haven't before, right? Usually on Mondays I have a band pick of the week. Band pick of the week is Orville Peck. Anybody heard anything about her? Oh, okay, yeah. Did a tune with Shania Twain. He's a Canadian country western singer. So I think his first album came out in 2019. So anyway, you might just take a listen to Orville Peck when you get a chance. Anyway. Why does it have that shape to it, right? It has that shape because what do you assume? In 202, you assume diminishing margin utility, right? So if you have diminishing margin utility, and you notice this is the slope, what's going on? As you get more x and less y, the margin utility of x is going down, right? And the margin utility of y is going up. So what does that mean? That slope's getting flatter, right? So if what you would do, and what did you assume in 202, right? You assumed diminishing margin utilities. And so what did that do? That drove the shape of your indifference curve to being convex, okay? So again, when you sort of think about why did you assume diminishing marginal utility, I mean, it makes some sense, right? The third hot dog that you eat doesn't give you quite as much utility as the second hot dog. Or the fifth hot dog doesn't give you as much as the fourth hot dog. The only exception to this rule that I have seen is my wife's shoes. My wife has so many pairs of shoes, and yet if we go to a store, the first thing she wants to do is check out the shoes. So anyway, that's my one exception to that. All right. Now let's, what did I do? I have to put my thing back on here. All right. So now for the next stage, let's talk about on the cost side. What we're going to do is we're going to look at the budget constraint, right? So what are we assuming? We're assuming that you maximize utility, right? And if you're maximizing utility, if you don't have any budget constraints, what's going to happen? You're going to keep going out and going out and going out, right? But you don't have a infinite amount of money usually. Although I was watching the quarterback for Kansas City that my wife is a big fan of, and I think he just signed a $25 million contract with Kansas City. But anyway, for most of us, we don't have that kind of money, so we have a budget constraint. So if we were to draw a picture of the budget constraint, we'd say, okay, how much Y can you buy if you spend all your money on Y, and how much X can you buy if you spend all your money on X? Okay, so if we spent all our money on Y, we'd end up with this much Y, we wouldn't get any X. And so what is this thing? This is some sort of budget, so how much money that you have. Let's say it's $100. And given the price of X and given the price of Y, how much can you how much you can buy is along there. So what is your budget constraint? Well, we're going to let I equal income. We're going to say, well, that's the amount of income that you have. And that's equal to the price of X times the amount of X plus the price of Y times the amount of Y. So if you had, if Y cost $2, you can buy so much Y. If you could buy 50 units of Y if you didn't buy any X, and if X, the price of X were $10, you could buy 10 units of X. So now, going to do the exact same thing, right? We're going to look at what's the slope of that budget constraint. So if we look at the change in income along there is 0. Right? That's what that represents. So the change in there along there is 0. And what is if we again take if you've had, most of you had calculus here, if you take the total derivative, what are you going to get? You're going to get di is equal to the price of X times dx. Make that a little bit lower here so it doesn't look like it's px. Price of X dx plus the price of Y dy. And we can do the same thing of just solving then this equation, and we solve for dy dx, which is the slope. When you solve for dy dx, what are you going to get? You're going to get a minus. You're going to do the exact same thing, right? You're going to get minus px py. Okay? So along the budget constraint, income stays the same, and we are given the price of X and the price of Y. And so what does the maximizing individual do? They try to have the highest utility, right? If they're going to maximize utility, the highest utility they can get given what their income is. So if we have y and x, we have our budget constraint here. And what do you, so again, remember that when you were in Econ 202 or whatever, you were talking about, I'm trying to, given my income, maximize utility, and what's given to you, the price of x and the price of y are given, right? You don't get to choose what the price of x and the price of y is. Or you, and everybody's small enough that their demand can't affect the price of the good itself, okay? So, so there's your budget constraint, and what are you trying to do, right? There's U0. That wouldn't be a good place to stop, right? Because if what you did is you were spending your money there, right? You could always move in here and increase your utility. So the only point where you can't increase your utility is where they're tangent to one another, right? If they're not tangent, if you have some sort of intersection, you can't be at a maximum. So as we move the indifference curve out, the one that's the farthest out, maximize utility, those slopes are going to be equal, all right? That's what happens when they're tangent to one another. Their slopes are equal. So if their slopes are equal, what do we know? We know that the margin utility of x to the margin utility of y is equal to the price of x to the price of y. So what does your constraint then say? It says that the marginal rate of substitution has to be equal to the price ratio. Okay, so that's going to be what maximizing utility or an individual at maximized utility does in a competitive markets where prices are given. All right. Now let's take a look at what happens if the price changes. All right. So what if we were to increase the price of x? Right. So we're going to increase the price of x. So we start out assuming that you're maximizing utility. Now, if income remains the same, and if the price of x goes up, and the price of y remains the same, right? So that's all we're doing. We're changing the price of one good, and we're not changing your income. So all we're doing is changing the price of x. Well, if you spend all your money on y, you could still buy the same amount of y, right? But if you spend all your money on x, you can only buy this amount of x. You can't buy as much x as you did before. So what we would do is we would draw our new line here, and this is going to be the amount of x that we bought, x0, the amount of x that we bought to start with, okay? But now you can't buy that same amount of x because it's beyond your budget constraint. So I'm going to find a new tangency, which is going to be, call that U1. And that's the new tangency where the new budget line is tangent to the new indifference curve, right? So we have a new budget line, right? We had P of y and I stayed the same. And we had the price of x going up. Well, now what's happened? Now we've got the amount of x that we're going to buy goes to there. Okay, so we have a reduction in the amount of x that we're buying. So just jumping ahead a little bit, if we were to put a tax on gasoline, right? What would happen? If we were to put a tax on gasoline, then you go in and you go to buy, and the tax is on the consumer, okay? You go in to buy the gasoline, you can't buy as much gasoline as you used to with the same income. So we would have rotated this in, and that would, a tax on gasoline would result in less gasoline being purchased. But there's two effects to that, right? First of all, there's what we call the substitution effect. And what the substitution effect is about is that we've made a relative price change, right? X has gotten more expensive relative to Y. Right? So we have a relative price change. Okay? And so what will happen? You'll buy less of the good, right? Because we have the price of X go up. But part of that happened because there was also a reduction in your income. Right? There was a reduction in your income because now you can't buy as much as you did before, right? All that area above the new budget line and up to the old budget line, you can't buy that stuff anymore. So your income went down. So I had two aspects of what happened when I altered the price of X. I changed the relative prices, but I also reduced your income. And so what we want to do is distinguish between these two things because when we go to look at a tax change, when we look at a reduction or an increase in the price because we've taxed something, I got two effects going on. One is I've changed relative prices, but I've also changed people's income. But if I wanted to compare two taxes, both of which raised the same amount of revenue, they would both have the same income effect. Okay? So what we want to examine then, in terms of an efficiency standpoint, we're going to want to look at the substitution effect. We want to look at, okay, how much of what we did in raising the taxes caused people to change how much they bought of this good relative to the other good. So if we were to separate those out, the way to do that would be to say, okay, what if we took the new budget line and we made it tangent to the old indifference curve? Okay? So it would be as if we gave you enough income back. We've changed the price ratio, but we've given you enough money back to get you back to the old indifference curve. So what we would do is now we're going to put the new budget line, we're going to put it tangent to the original indifference curve, okay, to U0. Now, if we do that, then we go, okay, here's we're going to take this thing and we're going to make it tangent and we'll get something that looks, let's say, along there. There's would be a new tangency, okay? Now, the way I drew this, we'll call that x2. The way I drew this, the income effect now is the total effect minus the substitution effect. Okay? So when I move the budget line in, then I take the new budget line and I make it tangent to the old indifference curve to get the income effect out of there. And now I'm going to have a substitution effect. So the substitution effect is going to be, the substitution effect is x0 to x2. And then the income effect, so that's the substitution effect. And then the income effect is the total effect minus the substitution effect. So it's x1 minus x2. Okay? So by raising the price of x, what I've done is I've changed the relative price of x to price of y. That's going to be the effect from x0 to x2. And then I also had an income effect because people's real income is less. And so I'm going to move from x2 to x1. So the total effect is x1 to x0. And I can now have looked at what the effect has been just from the fact that I've changed relative prices, and then what happened because I changed your real income. Now, notice that the substitution effect will always have you buy less of the good that's price went up. You'll always buy less of the good that had its price go up. And why is that? Because what you've done is you've assumed diminishing margin utility. Because you assumed diminishing margin utility, you made the indifference curve convex. So it would be impossible to take the steeper line and end up being tangent to the right of where you were, right? Because if that thing has decreasing slope, when I've made that the budget line have steeper slope, I've got to get a tangency which is to the left of the one I had before. So the substitution effect is always going to have you buy more. Buy less when I raise the price. But we, again, thinking back to Econ 202, you have normal goods and you have inferior goods. Right? And inferior goods have the quality that as your income rises, what happens? You buy more of them. Yeah. For an inferior good, as your income falls, you'll buy more, right? For an inferior good, like, I don't know, ramen noodles probably. You probably buy more ramen noodles today than if you've signed your $25 million contract with the Kansas City Chiefs. You're probably not going to buy as many ramen noodles as you did before, right? So that for an inferior good, you buy more of it as your income's falling, or you buy less of it as your income rises. A normal good, you buy more of it as your income rises. So it's possible then, if I had drawn this, I could draw an indifference curve and a budget line that what would happen is the substitution effect would be here and the income effect would go that way, right? So I could, in fact, I could do it so that, I'm going to do a new one of these. I don't know that I'm going to like this. I have to go back to chalk. Right? I could start out here at U0, and I could then have a new, we have y and x here. It's possible that I could end up with an indifference curve that the substitution effect then was here, right? So we go from x0 to x1. But I end up with a tangency that's in between there, right? I could end up with a tangency that's in between the two. And if I did that, then what would happen is that good would be an inferior good, right? Because the substitution effect has me buying less, but the income effect has me buying more. It's possible that you could have a good that was sufficiently inferior that you could raise the price of it, and the income effect would outweigh the substitution effect, depending on how you drew the indifference curves. But for a normal good, the income and substitution effects are going to work in the same direction. For an inferior good, the income and the substitution effects go in opposite directions. Now, it's probably fairly unusual that you would have a good that was sufficiently inferior that the income effect would outweigh the substitution effect, but it's certainly possible. You can, if you want to, you can could draw an indifference curve and budget constraint such that you'd end up with x2 being off over here. But the point here then is we want to take a look at what the optimality condition is, right? Which is the marginal rates of substitution has to be equal to the price ratio, and I'm going to separate out those two effects when I look at for tax law, right? If we're really thinking about it, if we think of when I'm going to take, let's say I have a bucket of water, or let's say you have a pool of water and you got a bucket and you're trying to take the water out of the pool. What I'd like to do is make it so that if I'm doing tax policy, I'm sort of slipping the bucket in there and taking it out so I'm not disturbing everything. If I just sort of splash it all over the place, then that would be sort of more inefficient. So if I know I've got to take out a bucket full of water, or in a sense I know I've got to take out $5 trillion in taxes, I'd like it to do it in a way that minimizes the other stuff that you're going to do. So I'd like to minimize that substitution effect when I'm looking at tax policy. Notice also that, has anybody ever derived the demand curve doing this? Well, if you sort of think about it, that's the way you can derive a demand curve, right? If what you did was what I did was I had y and x here, and I start out u0, and that corresponds to some price of x, then I could put the price of x here, and what would happen? I'd get x1 here, right? And that would be some price of x1, be there. Now, if I increase the price of x, then what's going to happen? This thing's going to shift in, right? If I decrease the price of x, this thing's going to shift out. Because when you draw a demand curve, what do you assume? When you draw a demand curve, you assume that income stays the same, right? And you assume that the price of other goods stays the same when you drew a demand curve. So if you drew a demand curve, what you'd be doing is saying, okay, income stays the same, the price of y stays the same, so this axis stays fixed here, and then what are you doing? You're rotating this thing back and forth as you change the price of x. And as you rotate that thing back and forth, what will happen? You'll get x1, and then let's say I decrease the price of x, right? And then I'll get I'll make that x0, okay, for the u0. So let's make that x0. So then if what I did is I decrease the price of x, then I'd make it px1, what's going to happen? I'll get an x1 there, and that's bigger, and you'll draw a demand curve that looks like that, right? So again, diagrammatically, or drawing a picture of when you told the story that said, when I got to fix the price of other goods and keep keep my income the same, and then I change the price of x, and that's what gives you my demand curve. And if you changed income, you shifted the demand curve, or if you changed the price of substitutes, you change the demand curve, or if you change the price of complements, you change the demand curve. Okay. Well, that was coming from this thing here, right? So just little aside here. So deriving demand curves is just a matter of doing what we just did, taking the indifference curve and setting it the budget line tangent the indifference curve. Now, we do the same thing for producers. What did you assume? You assumed that individuals maximize utility, but you also assume that producers are out there doing what? They're going to minimize costs because they're going to maximize profit. So in order to do that, So what did you do? You drew, right, a marginal cost curve, and you drew an average total cost curve, okay? But that isn't the only average total cost you could have if you were producing X and you had dollars here. That isn't the only average total cost, right? You could do it in a way that was way more expensive, right? You could do it very inefficiently. You could hire many more people than you really needed and had a bunch of them sitting around. You could, have too many robots or whatever, and a bunch of your robots aren't doing anything, but you paid for them, right? You could have lots of different ways. So this cost curve that you drew, when you drew the average total cost curve, must have been the cost, the minimization of the total cost curve, and from that you derived the average total cost. So you must have been looking at what's the minimum marginal cost, not, you could have large amounts of marginal cost, but the one that you put in there, when you put the cost function in there, you must have met the minimum. So if we were to look at a diagram of that, it says, okay, what am I trying to do? I'm trying to minimize the total cost. So let's say we have capital and labor. And I've got a certain amount of output I can make with capital and labor, given what the technology is, given what my production function looks like. Right? Because you assume some sort of production function when you made a marginal cost curve or a total cost curve. So when I think about what my cost is going to be, I'm going to be looking at what I'm trying to do is I'm going to try to minimize this cost. And what is the cost of producing something? Well, I got to have some sort of production function. So quantity is some function of capital and labor, right? So if that quantity is a function of capital and labor, if I were to look at what's called the ISO cost, which is sort of the equivalent of your budget rate in some sense, the ISO cost is the same cost. Everything costs the same there. So given this ISO cost, what are we going to have? We're going to have, that's the amount of cost, and we're going to have an isoquant, and what does ISO cost? ISO costs have the same cost, and isoquants have the same quantity. Just as we had an indifference curve where your utility was the same everywhere and you had a budget constraint which was the same amount of income everywhere, you get the same thing that's going to go on in this arena. So if when I'm going to look at the isoquant, I would have something that looked like that. Okay, so there's some quantity, let's say Q1, and if I use a lot of capital and not much labor, I can produce, let's say that's 100 units, say 100 units. I could use this much capital and this much labor. I could use more capital and, less capital and more labor, right? So I'm moving along here. Now, notice that we drew it convex, okay? If I drew it convex, what must I have assumed if I'm looking at an isoquant that has that shape to it? What must I have assumed? Yeah.
Diminishing marginal returns for capital labor.
The diminishing marginal product of labor and a diminishing marginal product of capital. That's what you guys assumed in Econ 202. Well, when you assumed so that if you have a diminishing marginal product of labor and you have a diminishing marginal product of capital, what's going to happen? You're going to get you're going to get that assumption, that shape to it. Because if we look at, we're going to do, just exactly the same thing. Along an isoquant, the change in quantity is 0. And what is we said this was a function of capital and labor. So if I look at what's the total change, it is the partial derivative of Q with respect to capital times the change in capital plus the partial derivative of the Q with respect to labor times the change in labor. Or if I change capital a little bit, how much does that affect the quantity of that's being produced? And of course, just as when we just did the margin utility of the margin utility of X and the margin utility of Y, what have we got here? This is the marginal product of labor, or excuse me, marginal product of capital here. So what do we have? 0 is equal to the marginal product of capital times the change in capital plus the marginal product of labor times the change in labor. And if what we do is we solve, we can do the same thing, and we can solve for the dkdl, right, which is the slope of this isoquant. And what do you think you're going to get, right? We're going to get minus the marginal product of labor to the marginal product of capital. So the slope of that isoquant is equal to the negative, because it's downward sloping, right? So it's equal to the negative of the ratio of the marginal products. Now the ratio of the marginal products is called, anybody know what that's called? Marginal rate of technical substitution, right? The marginal rate of technical substitution. That's just economic terminology for that. But basically, we're looking at we need to that the slope of that isoquant is going to be equal to the ratio of the marginal products. Now, what am I trying to do? Given an amount of Q, I'm trying to minimize the total cost of producing that. And what we need to do there is, just as we had a budget line, now we're going to have an isocost curve. Right? So let's go ahead and just look at the isocost. And we'll do the same thing as we just did in terms of drawing a graph dealing with capital and labor. And of course, this is going to look like what we just did on the utility maximizing consumer. We're going to have an isocost, and what is that? That's going to be some cost is the same everywhere. And so what am I going to have? If let's say it's $100. If I have no labor and all capital, how much capital can I buy? Right? If capital costs $5 a unit, then I'd have 20 units there. Okay? If I have this cost here of $100, how much labor could I buy? If I don't buy any capital, I could buy that much labor. And what's going to happen? I'm going to get a straight line that looks like that, right? And so what is the cost going to be, right? The cost is equal to the price of capital times the amount of capital plus the price of labor times the amount of labor. Right? It looks like what we just did with when we're looking at the budget line. Okay, so now what we have is we can do the same thing. The change in the change in cost along there is going to be 0, right? And if we were to take the first derivative, or take the total derivative of the cost function, what do we get? That's equal to pk dk plus pl dl, just like we just did with the budget line. And the price of capital and price of labor are here because they're a constant, right? So we can take the derivative. It just shows up, okay? So what does that end up with? That's going to end up with dkdl, right? You're going to have a minus sign because it's downward sloping, and it's going to be the price of labor divided by the price of capital, okay? So when we were doing utility maximization, you had the budget line, and you were trying to get to an indifference curve that was far out as possible, okay? But you're cost minimizing here. So the idea here is, given the quantity, what can you do? What's the least amount that you can spend? And what's the least cost for producing any given level of output? So if we're looking at 100 units, Q1, what's the least cost that you could produce it at? Well, you take your isocost line, and what would you do? You'd keep going. You'd have one here, okay? Which means that I could use that much labor and that much capital to produce the 100 units, but that results in a cost which is higher than if I were to move this way, right? So what am I going to do? I'm going to keep moving the isocost line until it's tangent, right? That's going to be the lowest cost. The lowest cost is going to be where I keep moving that isocost line in until it's tangent. All right, so I'm going to move the isocost until it's tangent. And when they're tangent to one another, slopes are the same, right? Right? So when they're tangent, the slopes are the same, and so what are you going to end up with, right? You're going to end up with that those slopes being the same. I got to have that the marginal product of labor to the marginal product of capital, right, is going to be equal to the price of labor to the price of capital, right? So that the marginal rate of technical substitution has got to be equal to the price ratio, which is basically what we just did on the other side, right? We ended up with the marginal rate of substitution has got to be equal to the price ratio. What's going to happen is we're going to show you that in a competitive market, that condition is going to hold. Just as in a competitive market, that first condition about the marginal rate of substitution being equal to the price ratio is going to hold. What do you need to assume that, right? You're going to have to assume things like prices are fixed to the consumer, right? And prices are fixed to the producer, all right? What did you assume? You assumed that everybody that was producing a good ended up, they couldn't alter the price of labor and how much labor they could buy, right? And maybe when you did a monopsonist, you might have done something like that, or when you did a monopolist, you might have had something where the prices depended on how much that individual did. But in a perfectly competitive market, everybody's taking prices as given. So if we look at that, what's going to happen for the cost minimization is going to require that the ratio of the marginal products is going to be equal to the price ratio of capital to labor. Now, notice also that when we were looking at the ratio of the margin utilities equal to the price ratio, we also have the margin utility of X to the price of X has got to be equal to the margin utility of Y to the price of Y, right? And what would that tell you? That the margin utility per dollar that you're spending on X has got to be equal to the margin utility of dollar you're spending on Y. And you get the same thing here, right? That the marginal product of labor to the marginal product of labor, to the price of labor has got to be equal to the marginal utility of, the marginal product of capital to the price of capital, which says that I got to get as much added product out of a dollar spent on labor as I do as a dollar spent on capital. But because if you didn't, you'd be better off spending more if you were getting more marginal product per dollar out of the capital, then that's what you should be spending it on, and using more capital and less labor. So notice that you could generate then this total cost function, just as you could generate the demand curve. What do? You can generate your total cost function, right? And so as I just said a moment ago, that if I were to draw a total cost function, when you draw that in Econ 202, you're actually drawing the minimum total cost function. And so if I were to put total cost here and Q here, it would look like that. Now, what's going to happen to the slope of that thing? The slope of that thing's probably going to be going like that, right? Because you presumed increasing marginal cost, but why is increasing marginal cost happening? Because you assumed diminishing marginal products, right? So when you assumed diminishing marginal products of capital and labor, you ended up assuming diminishing marginal costs, and when you did that, you ended up with a total cost function that was getting steeper as Q went up. So again, we could, well, we got a couple minutes here, but if you think about it, you could also look at the effect on the income and substitution effects if we looked at a payroll tax, for example. If we taxed capital, if we taxed labor, let's say you have a, what do you have? You have a payroll tax, right? You pay 12.4% in Social Security tax, and then you pay, I believe it's 2.9%. I forget what the Medicare tax is right now. But so you've got a payroll tax, and so what are you really doing? You're taxing labor, right? So here's my ISO cost, right? So here's Q is equal to 100, right? And let's say this is, $100 for the ISO cost. If I were to tax labor, what are you going to get? The same story that we just did, right? I didn't tax capital, right? If I didn't tax capital, then if I spent the $100 on capital, I could still buy that much capital, but now I can't buy as much labor. So what's going to happen? I'm going to get something that looks like that, right? And I can then, so now what's happened is that Q is going to be lower. The cost is the same, right? But I'm producing less. So what I must have done is I must have increased the total cost of producing any unit of goods. And I'm going to have two effects then, right? I'm going to have an income effect, and I'm going to have a substitution effect. So what the equivalent of the income and substitution effect. What's going to happen is I'm going to be able to produce less goods, right? And I'm going to substitute capital for labor. So if I were to put a tax on labor, I mean, really, if you think about it, minimum wage is sort of like that, right? What's going to happen if I increase the minimum wage? What am I going to do? I'm going to end up with less output because now it costs more to produce the same amount, right? And I'm going to substitute capital for labor. Now, when the president-elect in his speech talked about the increasing the minimum wage, he didn't say, oh yeah, and that's going to cause an income and substitution effect, and you know, we're going to substitute capital for labor, and da-da-da-da, right? So what we're going to try to do is get you to observe these sorts of things. So we will finish, I think we'll pretty much finish the appendix now, and then what we'll do is we're going to start looking at the efficiency aspects, and then what we're going to do is we're going to start looking at things like externalities where you have problems where the market isn't going to solve that. So go ahead and finish the appendix to chapter 1.